Morning.
Good morning, everyone. Greetings of the day. Do I am audible properly?
Yes, ma'am.
Yes.
I am Dr. Shruti Rawal from the Department of Mechanical Engineering, Faculty of Technology, Dharamsi Desai University. Respected Dean, Faculty of Technology, Professor K. N. Seth, sir. Respected Head of all the departments of Faculty of Technology. Our guest speaker, Dr. S. Vinod, sir. Mittal Zaveri, sir. Debashish Majbudar, sir. All the professors, teachers, research scholar, and the industry person who are participating in this FDP. On behalf of Dharamsi Desai University, I warm welcome all of you to the inaugural ceremony of Atal Online FDP on Lean Six Sigma. To fulfill your expectation with this FDP and to conduct this FDP smoothly, I would like to request all the participants to please observe the following instructions. All the registered participants are here request to join the session on time as per the schedule. To qualify for the certificate, minimum 80% of the attendance is required. So please try to attend all the sessions. Participants are also requested to join the Google Meet using the mail ID registered on the Atal portal. This will help us to identify your presence for the attendance. Participants are requested to keep their audio video in the mute mode during the session so we can run the program smoothly and quickly. You can interact with the expert after the completion of the sessions. Participants are also requested because to check the status of their approval to the Atal FDP as only approved participants have the certificate from the Atal. Now, I would like to request Professor K. N. Seth, sir, Dean, Faculty of Technology of Dharamsi Desai University, to say few words to motivate our participant. Sir.
Hello.
Yes, sir.
Okay. So, very good morning to all. I think my video is not on. Okay. See, on the occasion of this inauguration function of this online faculty development program on Lean Six Sigma, I welcome you all the participants and the expert speakers on behalf of our Vice Chancellor, Dr. H.M. Desai sir, and our Director, Sri Ankur Desai sir. At the same time, I facilitate the coordinators, Dr. Shruti Raval and Professor Jaideep Singh Ji Rawalji, to put all the efforts to organize this faculty development program on Six Sigma and Lean. That is a very important topic in this context. Professor G.D. Basan, head of the Mechanical Engineering Department, and all the staff members are actively involved into this endeavor. Dhamsi Desai Institute of Technology was started in 1968 as DDIT. The brand name is still DDIT, and it has become a university from 2005. This is considered to be a well-respected and a recognized university of Gujarat. Now, in this university, we have Faculty of Technology, Management, Pharmacy, Dental Science, as well as from last 3 years, we have introduced Faculty of Medical Science. Our Dr. N.D. Desai Hospital has served Nadia and the people around Nadia for COVID pandemic. We have a 300-bed dedicated COVID hospital during this time. Now, this FDP is offered under Atal Academy. We know that till the 2010-12, all the earlier faculty development programs were called summer school and winter schools, and they were offered by IST. Okay, but now since the faculty development programs are linked with our salary, senior scale and selection scale, and with the large number of colleges or institutions being introduced as self-financed colleges, the requirement was manifold, and hence AICTE took over this charge, and through Atal Academy, they are offering large number of faculty development programs. So even in the last year, they have offered more than say 96 programs, and more than 1.5 lakh participants have taken the benefit out of this program. This FDP on Six Sigma is also very well received. There are 200 participants, which is the maximum number allowed for an FDP. And we have expert speakers also. So we hope that there will be best learning and knowledge sharing amongst the participants and the experts. Basically, if, as I understand, Lean and Six Sigma, these are two different principles amalgamated together, so that instead of manufacturing sector, it can be used for the service sector also. Six Sigma was basically purely for manufacturing, for upgradation of the manufacturing, and it is the sigma is the coefficient of variation. So that coefficient of variation taken up to 6th level, it gives minimum defects, that is 34 per million, and that is the mathematical background for the Six Sigma. Whereas Lean is having a qualitative background, it is the minimization of waste. Lean is the minimization of waste and creating the value stream map. Okay, so with this Lean Six Sigma, I think this will be useful for the academic part also. It is not that wastage is not there in the academic developments. Okay, so the concept of the Lean Six Sigma, as I understand, it can be very well implemented for the academic purpose also, and all the experts and participants together will brainstorm how the principle can be brought into the academic area. Lastly, I would say that any learning in engineering, any learning of theories in engineering without being put into the practice is of no use. And any practice without adequate theoretical background is dangerous. Okay, in architecture and medicine, practice is prerequisite. Okay, any professor, if he is in the academics, practice is the prerequisite to become a professor. In technical education, lacuna is professor without practice. A professor without practice is like an idol of deity without consecration or pran pratishtha. Okay, even if it is a 120 feet idol standing in a mid of the Sursagar lake of Vadodara, nobody will worship. It is for inspiration or aesthetic. Okay, but if there is an idol with consecration, a finger size lingam will lead you to the moksha. So what is required in academics is every professor must have the practice. A professor with number of research papers and number of awards is like that idol in the Sursagar Lake, 120 feet high, but will not be useful for worship. Okay, so that's what I understand for the professor. The main lacuna of technical education is most of the professors are without having a practice exposure. Okay, so this is all from my side. I wish you all the best. Again, I felicitate the coordinators and the Department of Mechanical Engineering for putting all the efforts and bringing this particular school to DT University. I wish you all the best and have a nice time and nice interaction with the experts and the participants. Thank you. Thank you all.
Thank you very much, sir, for your kind words. Now, I would like to request Professor Dr. G.D. Basant, sir, Head of the Mechanical Engineering Department, to inform our participant regarding the Atal FDP.
Good morning to all of you. Can I be audible to all?
Yes, sir. Good morning, sir.
Good morning to all of you. And as Professor K.N. Seth, sir, our Dean, has told a number of things which are very useful to be a good teacher, an ideal teacher. Now, Honorable Vice Chancellor Dr. H.M. Desai, sir, who is the main inspiration behind the entire university, respected Campus Director Shri Ankur Desai, Dean Professor K.N. Seth, sir, all head of the departments, speakers of today's sessions, and dear participants. Very good morning to all of you, and thank you for joining the inaugural session of this FDP of Rejuvenating Learning with World-Class Business Improvement Approach, Lean Six Sigma, organized by our Mechanical Engineering Department, Faculty of Technology, Dharamsi Desai University, Nadia. Now, the Mechanical Engineering Department is in existence at DDU since the inception of the university in 1968, as our Dean Sir has told you, and was working as a supporting department for other engineering branches. Now, in 2010, the department was developed full-fledged and initiated BTech program in mechanical engineering. Now, since 2015, the department also offering MTech with specialization in CAD/CAM and PhD program in automation technology, tribology, machine design, automobile engineering, Lean Six Sigma, and advanced manufacturing technology. And the number of PhD scholars, they are going to be increased drastically. The department has over 20 instructional and research laboratory which are equipped with state-of-the-art scientific instruments and systems. The department is successfully running the number of chapters like the ISRE student chapter, SAE student chapter, and Mechanical Engineering Student Association, that is to be called as a MESA. Now, to foster techno-managerial skills in our students, the department frequently organizing professional trainings such as Green Belt in Lean Six Sigma and Black Belt in the Six Sigma also. Now, as Professor K.N. Seth sir has told you, that is Lean Six Sigma is an amalgamation of two philosophies. One is that is known as Lean, that focuses on the reduction of the several industrial wastages, okay, where Six Sigma emphasis on continuous process improvement. Now, today, all the engineering industries, okay, whether there is a process industry, healthcare industries, chemical industry, banking industry, IT industry, they are implementing Six Sigma and the Lean tools to raise their profit, productivity, safety, equipment efficiency, and employee involvements. Okay, even in the teaching field, as Professor Seth has told you, we can implement the Lean Six Sigma to improve the involvement of the teachers, to improve the efficiency of the teachers, and the other aspects also. Therefore, we select this topic for our faculty development program. Now, let me tell you the major highlights of this FDP. Now, it has a record break 200 participants that will attend this FDP, as it is to be limited by the AICTE approval. The course content of this FDP is at par with the training provided by famous knowledge bodies such as KPMG, ASQ, MSME India, etc. The speakers of this FDP belong to world-class institutions and consultancy companies with a tremendous grip on all these topics. A schedule will be followed meticulously during these 5 days, and total 14 sessions that would be delivered without any problem. That also will be the hands-on sessions on Minitab software, so that you can understand these topics easily and efficiently. I am very much sure that these 5 days you are going to enjoy learning of this business excellence methodology, and it will be useful in your professional life also. With this, I am not taking your much time, and I conclude my words, and I announce that the FDP is now on. Thank you very much, all of you, and good luck. Thank you so much.
Thank you very much, sir, for your kind words. Now, I would like to request Dr. S. Vinod sir to conduct the first session. I'll take the opportunity to introduce our today's first speaker, Dr. S. Vinod sir. Sir is currently working as the Associate Professor in the Department of Production Engineering, NIT Tiruchirappalli. Sir has the total of 14 years of experience as the academician. His area of expertise are lean production, sustainability manufacturing, Lean Six Sigma, multi-criteria decision-making, additive manufacturing, product design and development, Industry 4.0, smart manufacturing, and digital manufacturing. Sir has published more than 100 research papers in the reputed journals. His several research papers on Lean Six Sigma were awarded as the outstanding paper. Now, I would like to request Professor S. Vinod sir to please take over the session. Thank you very much, sir, for accepting our invitation.
Thank you, Dr. Shruti, for the introduction. So let me proceed by sharing the content. Dr. Shruti, is the content visible?
Yes, sir.
Yes,
Okay.
sir. Yes.
So is my voice clear?
Yes, sir.
Okay, so Dr. Shruti, if there is any network interruption, kindly bring to my notice. I have my backup network, but still, because in Google Meet only I could see my presentation window only. So kindly alert me if there is any interruption. Okay.
Sure, sir.
Okay. So faculty, scholar participants, good morning all. It gives me immense pleasure to be a part of this faculty development program. I would like to congratulate the coordinators, Dr. Shruti and other organizers for taking up a very relevant topic for this faculty development program, Lean Six Sigma, one of the powerful business excellence methodologies. So in this session, I'll be focusing on lean manufacturing, Six Sigma and Lean Six Sigma, theoretical perspectives, practical case studies, and at the end, the research insights. So I request all participants to post your queries in the chat box, and interimly I will assign some time for discussion. So rather than having the discussion at the end, interimly we could interact. So kindly feel free to interact for any kind of clarifications. Okay. So with this, let me proceed with my content. So the first module of my presentation is on lean manufacturing. So here, for understanding lean manufacturing, let me spend some time on fundamentals, and then I'll move on to the kind of advanced concepts, and we could see parallel case studies and the kind of research insights. So in this way, we shall go ahead with the interaction. So if you could see the kind of lean manufacturing, when we want to understand, we need to have an understanding on the predecessor paradigms, especially the first manufacturing era started somewhere with craft manufacturing, where it is the kind of familial type of activity where one generation will do the task and the kind of skill set will be transferred to the next generation. Like a very good example, we could see the kind of the pot making, where they have their expertise and they do handle product variants, and they have their customer demand. Also, they go based on the forecast data, and they try to manufacture products, and the skill set will be transferred to the next generation and so on. So from such craft system, next we had mass manufacturing. As we are all familiar, mass manufacturing is characterized with high volume production with limited product variants. Especially here the focus is on the concept of assembly lines and so on. Especially mass production happened with maybe in the second industrial revolution, where we tried to utilize the concept of assembly lines and so on. So from mass manufacturing, lean manufacturing emerged, and in the third industrial revolution, we had a lot more deliberation on lean manufacturing, where the term lean implies it's lesser of everything. Maybe it could be space, inventory, people, time, and so on. Lesser of all these entities. And this is a lean manufacturing. It originated from the Toyota production systems from Japanese industries, where it is based on just-in-time approach. And in lean, the main focus is on waste elimination. Of course, we will discuss about the 7 forms of waste, and thereby we focus on streamlining the process and enhancing value addition and so on. So from lean manufacturing, next emerged agile manufacturing. So agile is how quickly an organization can respond to dynamic requirements of the customers. So in agile manufacturing, we'll be having much more technological integration, and we focus on customizing the products according to the varied preferences of customers and so on. We focus on customization and so on. From agile manufacturing, proceeded successively with the kind of sustainable manufacturing, where the focus is on developing environmentally friendlier products, processes, and how we can minimize environmental impacts and so on. Then from sustainable manufacturing, we are progressing towards smart manufacturing. So that's what in the industry 4.0, we are very much concerned about making the manufacturing system more smarter, and we are ultimately moving towards a kind of smart factory.
Vinod sir, sorry for interruption.
Yeah.
Yeah, sir, please make your PPT in a presentation mode.
Yeah, it's in presentation mode only.
No, sir, a slideshow, sir.
Yeah, it's in slideshow only.
Okay, but we cannot see in the slideshow. Full screen, sir.
Yeah, I have already kept in full screen mode only. You
The
couldn't
slide
see?
is not moving, sir.
Yes, sir. Slide.
It is in the
Yeah.
first.
It's not moving. Once again, let me once again. Yes, once again. Just a moment.
And I will.
Yeah, once again. Just. Yeah. To certain extent, I will keep in this mode, because in Google Meet always there is a minor drawback in this kind of slideshow mode. So is the content visible? I am in transition of manufacturing systems.
Yes, sir, visible.
Okay.
Yes, sir. Yes, sir.
Yeah. Fine. So thanks for bringing into my notice. Okay. So so we have been discussing about smart manufacturing. So in smart manufacturing, the focus is on the high levels of technology integration, especially Internet of Things, cyber physical systems, big data analytics, additive manufacturing, and so on. So now from this transition of manufacturing systems, we should try to understand, when we want to understand a particular manufacturing system, always we need to refer its predecessor manufacturing system. So as our discussion is going to revolve on lean manufacturing, so our discussion in most instances, I will try to map with its predecessor manufacturing, which is mass manufacturing system. So in this regard, let us try to now compare the craft system with mass manufacturing and with lean manufacturing. Now I am presenting the comparison of these three systems. Is the content rightly visible to you all?
Yes, sir.
Yes, sir.
Fine.
Yes,
Okay. Fine. So if you see the kind of focus, if you see in craft system, the activity or the task to be done is the focus. Whereas in mass manufacturing, the focus is on the product. Whereas in lean thinking, the focus is on customer, fulfilling the customer's demand, that is validation from customer's perspective and so on. If you see the operation strategy in craft system, almost it's like the focus is on single items and so on. They do have limited variance. And if you see in mass production, we'll be having this kind of batch and queue scenario. Whereas in lean system, we are trying to synchronize the flow. That means one process has to be synchronized with the next. So thereby, there will be no delay and there will be no accumulation of inventory. And we are focusing towards the pull system. We are trying to produce to customer demand. If you see the objective in craft system, it's mastery of craft. That means that they develop the expertise and they have that expertise to manufacture products. Whereas in mass system, we try to reduce cost and we try to increase efficiency. So the cost reduction, how it is happening in mass production, we are all familiar with the term called, the concept called economies of scale, which states that when you increase the production volume, the unit cost of a product comes down naturally. So we are trying to reduce cost and increase efficiency. In the sense, we are trying to utilize the resources and we try to produce the product. But we are not sure about whether there is a definite customer demand. So we are not sure about it. Coming to lean system, the focus is on waste elimination and we try to focus on value addition. That is from customers' viewpoint. Anyway, we'll be discussing in detail in due course as a part of it. I'm just trying to give a comparison between the three systems. Coming to the quality aspect in craft system, it's an integrated quality. In the sense, the workforce, they have the mastery of skills and based on the skills they try to develop. So the kind of products they manufacture, most likely the defects are less as a part of it. So it's an integrated quality. Whereas in mass production, we try to confirm quality through inspection, mostly like a kind of a stage inspection and so on. Whereas in lean system, it is included, quality is an included element of manufacturing. So how we try to bring in quality by design methods, design procedures, we try to make the quality as an included element of manufacturing. Okay, coming towards the business strategy next. In craft, we are focusing on customization. But in the sense, we don't have an exhaustive customization, but a customization to an extent. Coming to mass system, as we discussed about economies of scale, and we are focusing on automated systems like assembly lines and so on. Coming to lean system, we are focusing on flexibility. In the sense, in lean, we mean process flexibility. We are trying to make the process flexible to accommodate for few product variants. And we try to adapt the process to a certain extent. The higher extent of flexibility or higher extent of adaptability may not be so, but level best, we can make the process adaptable. Let us take a very simple example. I have a product line, I have an assembly line in which I need to manufacture 2 or 3 variants of products. In the context of a lean system, I can do so by adopting SMED and quick changeover concepts. So I can try to go for the quick changeover of the production tooling and I can achieve the kind of flexibility. So in the sense, the process is being made flexible and the process can be adapted to the varied customer demand. Next, discussing about the improvement in craft system, as we discussed, they have the mastery of skills, whereas in mass system, we are focusing on the expert-based continuous improvement. In the sense, the kind of a machine tool a particular employee will be operating. Of course, the same workforce will be handling that particular machine tool. So they have the expertise to go ahead with that particular machinery, but they don't have much familiarity on other kinds of machinery because their focus is on a repetitive manufacture of products. That is a repetitive type of activities for which we call it an expert-driven improvement. Coming to lean system, it's worker-driven continuous improvement. In the sense, we try to equip with workers the skill set and the kind of innovation. In lean system, innovation is very important. Okay, the process-based innovation is very, very important. That's a part of it. That's why we call worker-driven continuous improvement. So the kind of the solutions for the problems have to be brainstormed, how to be innovated, and those solutions need to be derived as a part of it. That's all about lean thinking. So this will give you a fair idea of the comparison between the craft system, mass system, and lean system. So next, we shall discuss about the fundamental waste in manufacturing process. So what is the meaning of the term waste? So waste is an entity that consumes resources but do not add value from customers' viewpoint. Here in lean, we are very much focused on fulfilling the value from customers' perspective. So if you see from the basic fundamental lean theory, there are 7 forms of waste. The first one being unnecessary transportation of materials and sub-assemblies, which happens in the layout. Second is inventory. So in the sense, in inventory means the stock of goods. So it may be either in raw material or in process, that is WIP, or it could be finished goods inventory. So inventory in any form is not desirable. So if you see the raw material and finished goods inventory, controlling them is a strategic aspect. Whereas coming to WIP, we'll be having very good control over WIP. It's a part of it. That's about inventory waste. So the third one, the kind of unwanted or non-productive movement of the workers, which happens in the layout, that is being accounted as a part of motion waste. Fourth one, waiting. So it is nothing but waiting or delay which happens for any reason. Maybe we are waiting for material, waiting for sub-assemblies, waiting for instructions, waiting for tooling, waiting for any kind of an action is considered as a waste. Next one is overproduction. So in the sense, lean system has to produce only to customer demand. We are focusing on the kind of a pull scenario. But if we try to produce more than the customer demand, for which there is no immediate taker, then it becomes an inventory at the manufacturer's end. And sometimes the products may become obsolete. There are associated issues as a part of it. Next comes overprocessing. That means inappropriate processing. We are trying to provide certain features in a product which the customer didn't ask for, because very important aspect in lean is every activity has to be paid by the customer. So in the sense, if you try to provide a feature, for example, when the customer has asked a particular type of manufacturing process to be done, when we go ahead with a higher precise process, then it becomes a waste. It's an additional processing for which the customer will not pay for. The manufacturer has to take ahead with that kind of a loss. So it becomes, so the processing has to be done only based on the customer's demand. Next comes defects. Maybe the defect may be either in the form of a scrap or rework or rejection. There's nothing but a kind of a non-conformance to the customer requirements. So these are the 7 fundamental waste in the lean theory. But if you see, as a part of the advancing theory, 8th waste had been brought, which is underutilization of workforce creativity or workforce skills, or there is creative skills. In the sense, as we have seen, lean system is based on the worker-driven continuous improvement. So the kind of innovation, innovative solution, innovative thought has to come from the workforce. So when such creative skills are not being utilized from the workers, it becomes a waste. It's part of it. That's called the 8th waste, underutilization of workforce creativity. And the 9th one, if you see from research perspective, they have brought environmental waste. That means exhaustive material utilization and kind of utilizing more energy-based resources and creating more, because all these things will create more environmental impacts. So such activities are being accounted under 9th waste, environmental waste. But if you take the lean theory, lean concepts could very well deal with the first 8 forms of waste, and the 9th one will be taken care by the sustainable manufacturing concept. But still, as I told, always a predecessor manufacturing system will have certain relevance. In lean, we say we have to produce to customer demand. That means resources have to be optimally utilized. It's an indirect implication we could derive from this statement. So which very good forms the foundation for the next manufacturing system, sustainable system. Right. So these are the 7 plus 2 forms of waste, 7 forms of waste from the basic lean theory, and the other 2 have been brought. Because we know pretty well the theory keeps advancing as a part. Right. Now let us spend some time and discuss. Already we discussed about the term lean and lean manufacturing. So lean implies a recognizing, identifying the different forms of waste involved in the process and trying to minimize and trying to ultimately eliminate them. Here we should be very, very clear. A directly elimination of waste is not possible. So very meticulously, we need to go ahead first with identification, because in a process stream when I should be able to identify what all the different forms of waste, where transportation waste is there, where motion waste is there, which one is higher, I should be able to recognize. Then I should explore the ways, how we can minimize. Then we have to go ahead with elimination. So it's a Kaizen approach. In lean, it's based on Kaizen approach. That is continuous improvement, step by step as a part of it. Incremental improvements, that is most essential. So if you see the lean manufacturing, it's considered as a business philosophy, which is based on continuous improvement, Kaizen, which has its focus on the process, because it's a process, lean is a process focused strategy. It completely takes into account the process dimensions, irrespective of the type of product, whether it could be an automotive or aerospace component or electronics component or any kind of a product may be. But lean is focused on the process, making the process perfect. Thereby the product made out of the process is perfect. That's the kind of analogy lean has. So in lean, we are trying to enhance the speed of the process. So in the sense, increasing speed means the process stream or the value stream should not go very fast. Because if they go very fast, they try to produce the product will be manufactured ahead of the customer has asked. But in lean system, producing ahead of the schedule is not permitted, or it is not accepted, because it will become an inventory at the manufacturer end, and it may become an inventory at the customer end, which the customer will not accept. So such aspects we need to take with utmost care as a part of it. So the terminology increasing speed means we are trying to make the individual process cycle times in compliance with the takt time. So we'll be discussing about all these time concepts in due course. Such compliance we try to bring, in the sense we are trying to regulate the speed. I prefer to call by the term, we need to regulate the speed in line with the customer demand. That's more essential. So as I mentioned, this lean concepts ultimately reduce cost, because here we are identifying waste, minimizing, eliminating them, and we are enhancing value and so on. And it can be applied to any kind of an industry, maybe an automotive component, aerospace component, electronics component, maybe process industries. It's not only for product manufacturing, but process-based industries, small-scale industries. Likewise, for all these kind of industries could be applied. So, okay. So when I want to understand this lean manufacturing, so we need to have an understanding on its elements, tools and techniques, and governing rules. So these entities are very essential for understanding a lean system. So in my presentation also, I'll be proceeding in the same pattern. Okay. So here, as I mentioned, the lean manufacturing facilitates a speedy process. In the sense, it tries to regulate the speed in line with customer demand. That has to be understood. And smooth, in the sense, it tries to minimize the fluctuations, variations, and so on. And economical manufacture, because we are trying to reduce the cost of a product by means of eliminating waste, by means of enhancing value from customers' perspective, and so on. That's why it's also called economical manufacturing. Okay, so as we discussed the term waste, so there are different forms of waste. Maybe it could be a scrap, rework, or it could be some downtime, maybe long lead time, excessive labor utilization, and underutilized machineries and equipment. Likewise, industries may have different forms of waste. Right. So as I mentioned, first I'll be discussing about elements. So there are 5 elements of lean manufacturing: customer value, value stream, value flow, customer pull, perfection by continuous improvement. Again, these elements are based on chronology. That means the kind of sequence of these elements need to be followed as a part of it. In sequence, we need to understand. Let us discuss further that how this chronology is being ensured as a part. Okay. So first we shall try to understand what is customer value. So here, in the context of lean system, customer pays money for the product. In turn, they want value for what they pay. That's why we are very much concerned about the kind of activities which adds value from customer's viewpoint, not from manufacturer's viewpoint, from customer's viewpoint. Any activity which do not add value from customer's viewpoint has to be minimized and ultimately eliminated. So here, we need to have an understanding on the various activities that contribute to value from customer's perspective as a part of it. So if I take a value stream, okay, after understanding the value from customer's perspective, I need to recognize those activities which add value, and I should see a value stream. The value stream is based on the SIPOC cycle: supplier, input, process, output, customer. So here it considers all activities from the receipt of the raw material till the product is being delivered to the customer. It involves the complete sequence of activities as a part of it, where every stage we need to ensure the resource is being consumed, in the sense cost is being incurred, value is being added as a part of it. That kind of a checkpoint we need to have. Say I have a drilling process, I have a milling process involved in manufacturing automotive component. So every stage, when I see the activities are being designed in such a way, each and every activity will consume resource, and thereby the cost is getting incurred and value is being added, and that cost will be paid by the customer. This kind of a checkpoint is very, very essential. So if we take value stream, there may be 3 types of activities. One is activities adding value, that is value adding activities. The The second one, activities necessary for completing the process, which is business value added or necessary but non-value added activities. And the third one is activities not adding value. There is non-value added activities or waste. So if we take a typical value stream, these three types of activities are prone to occur. Our ultimate objective is to minimize and eliminate waste and try to reduce the non-value added activities to the extent possible and to maximize the value added activities. So here, if you take value added activities, all the process chips which are involved in product manufacture, as I mentioned, where the cost is incurred, in turn value is being added. Such activities are called value added activities. Second one, necessary but non-value added or business value added. What are they? They are nothing but they are induced in the process either because of compliance with the government regulations or the kind of mandatory inspections we do without which the process could not be completed as a part of it. So such activities are called business value added or necessary but non-value added. They do not add value, but the complete process cycle cannot be closed without them. Such activities are called the necessary but non-value added, NNVA or BVA. Third one, the 7+2 forms of waste earlier we had seen. They are nothing but the waste non-value added activities. Definitely they have to be eliminated. Yes. Okay. So now we understood customer value and value stream. Next, value flow. In the sense we had said the value stream. Now the product has to flow across the value stream. How? On what basis? In line with the customer demand. That's why I mentioned the process value stream has to be regulated. That is, the product manufactured using the value stream based on customer demand. It's called value flow. And here we need to ensure that the value flow must be smooth. It should not have any bottlenecks. Okay. So maybe when we have a very poorly organized layout, it could be a bottleneck. Or the tooling is consuming more time. It could be a bottleneck. When the product design is not in compliance with customer requirement, it's a bottleneck. Or there is more downtime. Or a lot of waiting is happening. All these are nothing but the bottlenecks. So we need to eliminate the bottlenecks and ensure that we have a very smooth flow of product across the value stream. That's called value flow. So the next element being customer pull. Because here in Lean, we are focusing on the pull system, which is very contrasting to the push system. In push system, we try to produce based on the forecasted demand. We try to utilize the resources. We try to utilize different forms of resources, including human resources, and we try to produce the product, but we are not sure about the demand because there is no definite customer demand. It's a prediction. Whereas in pull system, we are producing only to customer demand. So thereby, totally we'll be able to control the inventory as a part of it. And there will be no issues in terms of product obsolescence and so on as a part. Once we make this is transform from the push system to pull system, then accordingly we'll be able to deal with all these issues related to the inventory and so on. Next, the last one is continuous improvement. Okay, because as we all know, Lean is a Kaizen approach. Continuous improvement, we have to go for perfection, step-by-step improvement as a part of it. So ultimately, we are trying to we have to sustain the improvements. Very important challenge in Lean is this kind of sustenance of the improvements. It's very critical as a part of it. So that's about the fifth element, which is perfection by continuous improvement. Now, as I mentioned, that these 5 elements, customer value, value stream, value flow, customer pull, and perfection by continuous improvement, all are driven by a chronology. In the sense, value flow cannot happen before value stream. Once you set the value stream, then only you'll be able to concentrate about the value flow. So it cannot happen prior to that. Or maybe like the pull system cannot happen prior to the value flow or value stream. So these elements are based on perfect chronology as a part of it. Okay. So now, so far we discussed about the fundamental concept of lean manufacturing. We had seen the comparison with the craft system, mass system, different forms of waste, and the elements of lean manufacturing, 5 elements we discussed. Okay, maybe let me take 1 or 2 queries if from the participants. Any quick queries from your side? Any queries till this stage?
Rajesh Patel sir, you raise your hand. If you have any query, you can ask. Rajesh Patel sir. Okay sir, there is no query. You can continue, sir.
Yeah, thank you. Fine. Okay, so now, as I mentioned earlier, in order to understand a lean system, understanding on its elements, tools and techniques, and governing rules is very essential. Next, we will move ahead with the discussion on tools and techniques. So from the fundamental lean theory, there are 4 primary or basic lean tools. That is 5S, total productive maintenance, TPM, value stream mapping, then work cell. And there are a set of secondary tools. Why there is a categorization of primary and secondary? Primary tools or basic tools are essential tools which are to be implemented for enhancing lean performance, and they are the prerequisites or the kind of fundamental activities to be concentrated in order to make the system lean. Whereas the secondary tools or augmenting tools, they will support the primary tools, and they have to be augmented with the primary tools, and we need to focus on the implementation. So there are a set of secondary tools which I'll be discussing. Okay. Let me proceed with a brief overview of all these types of tools, and in specific certain tools I will go in depth and show certain case studies to you. Okay, so the first primary tool is 5S. As we all know, 5S is a workplace organization tool, and this is a very important tool in the sense most of the problems, say for example the transportation waste or motion waste, it happens because of a poorly designed layout as a part of it. So when the layout is not being organized, it is a major problem as a part of it. So here 5S aims at making an organized workplace and ensuring the safer workplace, clean workplace. Thereby we can contribute to quality improvement, and it tries to make the workforce gain ownership, in the sense the workplace have to be kept clean. Such activities need to be done by the workforce automatically as a part of it. So here if you see, the 5S contains 5 elements, which are 5 Japanese terms: Seiri, Seiten, Shiso, Shiketsu, and Shishuki, meaning sorting, setting in order, shine, standardize, and sustain. So first we need to segregate the items which are in use and which are not in use. Next, those items we have identified in use, we have to put in an orderly way. That orderliness is an element, is an very important goal of the second element. Third one, we have to ensure that the workplace is clean. In the sense, items must be ready for immediate usage as a part of it. Whether it could be the kind of machineries or equipments or the tools, there should not be any dust or dirt, and they must be ready for immediate usage. Fourth one is standardization. So here we need to go for establishing the standards to ensure consistency as a part of it. In Lean, we always emphasize on SOPs, that is standard operating procedures, and SIs, standard instructions, because every shift different operators may work in the shop. We need to ensure consistency. How? By ensuring the procedures are standardized as a part of it. So the next one is nothing but sustenance. As I mentioned, almost the final step in lean implementation, in any form of lean implementation, will be sustenance, because whatsoever the activities we have done, they need to be sustained. We need to bring self-discipline, motivation, enthusiasm as a part of it. The operators have to do on their own. Once they enter the shop floor, they have to ensure the shop is clean. Once they are leaving the shop, after the shift is over, they have to ensure it's clean as a part of it. It has to be done by them without any push as a part of it. That's the challenge. So as a part of 5S, we'll be doing this kind of a red tagging. So those red tagged elements are nothing but the items which are not in use, which have to be segregated in a separate area, and slowly they may have to dispose as a part of it. So this red tagging is a very important activity we do. The second one is nothing but a kind of a always if you see the convention in lean system, is the left one shows the before scenario and the right segment shows the after scenario. The before after improvements will be shown. So that is the convention in lean system. If you see on the left, different tools are being put in a bin as such, whereas on the right we could see the tools are being positioned very orderly in an orderly way. Thereby, the operator who doesn't have much experience also will be able to take the tool and position back in the right place. Otherwise, a lot of time will be wasted from the left. When you want to pick from the bin, it will be very difficult as a part of it. So this is the concept called the shadow board, which is being used as a part of the lean, the 5S implementation. If we say this shadow board, it is in line with another concept of lean, which is called Pokayoke, which means mistake proofing. In the sense, this shadow board will permit the operator to take a right tool and put back in the same place without any issues. In the sense, without any difficulty or without any mistake, it will be done. So though it is a very simple mechanism, but it is an effective mechanism that we need to take into consideration. Fine. So this standardization, as we discussed, while we'll be doing 5S auditing. In the sense, we have to see to what extent these elements are being implemented, the 5S elements. So we do different activity. So accordingly, we try to frame a set of questions like a checklist, and we try to do 5S auditing to gauge the performance, to what extent we implemented 5S, for which we'll be taking the tool called the shadow board. Sorry, this is called the kind of the radar chart or spider chart. So if you could see, it will display the kind of scores pertaining to the 5S elements, and accordingly, this can be monitored periodically so that scores of different 5S elements could be depicted using the spider chart or radar chart as a part of standardization. So these are all some of the activities we do as a part of 5S implementation. So 5S, every lean tool is a very big theory. So I'm trying my best to present the salient features or the salient aspects of each lean tool within the time frame being given to me. That's the idea. Okay. So this, having understood about this 5S, next we will see total productive maintenance. That is called a TPM. So here this ends the TPM. If you see how it originated, earlier initially they tried to apply the TQM theory for maintenance related problems, but they didn't had very good compatibility. Next, they started applying preventive maintenance and so on, but later they realized that a separate maintenance philosophy is needed. That's the reason they brought ahead with the TPM, total productive maintenance, which focuses on complete involvement of the workforce to deal with this kind of maintenance related issues. Say we try to do the planned maintenance, predictive maintenance, and so on. Thereby these maintenance related problems could be solved and ultimately productivity could be gained as a part of it. If you see in TPM, we call this as house of maintenance or 8 pillars of TPM. Okay. So we do have autonomous maintenance. In the sense, the operators have to do their activities on their own, maintenance activities on their own. They have to be trained. Okay. A second is about equipment and process improvement. So where we are very much concerned about computing a index called overall equipment effectiveness, where we try to consider the availability, performance, and quality yield, and we try to do the like 7 ways to, we do have 13 losses as a part of it. Equipment, manpower, material related losses, we try to correlate and we try to come out with an index. So I'll be showing overall equipment effectiveness calculation. That's about the second pillar, where the focus is on ensuring the life of the machineries and equipments, and we ensure they are very much we very much focus on enhancing the effectiveness of the maintenance procedures. Okay. So the third pillar is about the kind of planned maintenance. So here in planned maintenance, very important aspect is nothing but we'll be focusing on the kind of maintenance activities as per the schedule, like daily, weekly, monthly maintenance, and so on as a part of it. So along with the scheduled maintenance, we have to go ahead with this planned maintenance also as a part of it. So that will be taken care by the maintenance personnel, and apart from that, we may have to train the shop operators on the maintenance related activities as well. Next is about, fourth pillar is about early management of new equipment, because if you see the new equipment in the initial period, there may be chances for the occurrence of the failure and they are being put into operation, because that is very obvious from the reliability curve if you see. So in the initial phase, the failures are prone to happen, and towards the end, after the useful lifetime, and again due to wear, the failures are prone to happen. That is very much obvious from the reliability curve. So the manufacturers, they take utmost care during the early operating period of the machineries and equipment. That's why the maintenance procedures and the schedule, they are very much emphasizing. When you purchase a new product, say for example like a two-wheeler, we try to purchase, or maybe like a four-wheeler, there are some initial maintenance activities which have to be done very much based on the schedule, and manufacturer is very much concerned about this. So that is an obvious example for this early management of new equipment. So the next one is, fifth pillar is process quality management, where because of the improper maintenance procedures, the quality related problems should not happen. So this pillar will take care of such quality related issues which happen due to improper maintenance procedures. The next one is TPM in office, which is administrative TPM, because we should try to understand all these maintenance procedures are not only for the shop floor or manufacturing related activities, but also to the administrative departments, because they provide all possible information related resources as a part of it. And again, these maintenance related activities are very essential. Next comes education and training, because we know pretty well, we have to train the workforce as a part of this implementation. So we have to go for periodic training and educating them as a part of it. So here, the operators' operational skills as well maintenance skills are more essential as a part of it. That's the focus of the seventh pillar, and the eighth one is safety and environmental management, where we are focused on the workplace safety and the environmental management issues as a part of it. Say for example, compliance with the safety environmental standards, and we are trying to minimize such safety and environment related risk, and accordingly we try to go ahead with the implementation. So these are the 8 pillars. As I mentioned, the equipment and process improvement pillar is concerned with overall equipment effectiveness, which is OEE, which takes into account the availability, performance, and quality. It implies the efficiency of the machinery or equipment during its planned operating time. So for calculating overall equipment effectiveness, we need to consider availability, performance, and quality yield. Availability is concerned with the downtime loss, performance with speed loss, quality yield with the quality loss. So these 3 losses have to be minimized as a part of it, and ultimately the overall equipment effectiveness to be focused. So as per world-class standard, overall equipment effectiveness should be 85% for machineries and equipments. Accordingly, it will be done for this OEE calculation will be done for machineries and equipments, and periodically it has to be analyzed as a part of it. Okay. So if you see this overall equipment effectiveness calculation, a very simple illustration I would like to show. Say for example, for a drilling and tapping center, when you want to calculate, the shift time is being given 8 hours, 480 minutes, and planned maintenance time, downtime, and average setup time are being given. These 3 time parameters have to be subtracted, have to be deducted from the shift time, and accordingly we know the available time. When we subtract all these time parameters in the shift time, we'll be knowing available time. Then we need to take availability as percentage, which is nothing but the ratio of available time to shift time. Then we got the availability as percentage. The planned production is being given 200 numbers. Actual production is 160 numbers. That means the performance efficiency is the ratio of actual production to planned production. We have about 80%. Next, the first time pass rate or quality yield is about 99%. When we take the product of availability, performance, and quality, we got OEE, we are getting around 64%. That means so a lot of scope is there for enhancing OEE. Because in this, we could see the setup time we need to reduce, downtime we can try to bring down, and the planned maintenance time also we can reduce, thereby the availability will increase. Similarly, there is a difference in 40 units. Only actual production is 160 units. We need to explore that why the actual production is 160 numbers. So accordingly, we need to take some actions as a part of it. So thereby, after computing OEE, we have to analyze and we have to explore the actions and we need to improve upon them. That's more important. Okay. So if you see some of the conditions which will ensure TPM success, first one is equipment effectiveness enhancement. Next, autonomous maintenance. Next, we have to focus on autonomous maintenance. As we have seen, we have to train the operators on operational and maintenance skills as a part of it. We will train them on different aspects of maintenance, so autonomously they'll be able to take care of certain maintenance activities. Next one, scheduled maintenance. So along with the planned maintenance, the scheduled maintenance is also very, very essential as a part of it. So we have to take care of both these aspects. Next one is nothing but skills improvement. If you could see this curve, the downtime is getting reduced as a result of training the people on TPM related initiatives. So this is a very good example that how the skills improvement is happening as a result of enhancing the skills, how the downtime is coming down and so on. Okay. So next one is nothing but is equipment management. So we need to ensure that for every machinery or equipment, the history codes, because the history code will contain what all the breakdowns have happened, how they are remedied, and what all the maintenance procedures done and what all the maintenance procedures to be done and so on. If there will be a history code for every machinery or equipment. Accordingly, we have to update the history codes, and also this spares management is also very, very essential, because depending on the criticality of the component, the spares need to be maintained as a part of it. So these are all the conditions applicable for TPM success. So this is about the second tool, TPM. So the next primary tool which we'll be discussing is value stream mapping as a part of it. It's again a powerful tool for lean system. So here in value stream mapping, it's a kind of a paper and pencil tool, and it will help us to indicate all actions needed for bringing a product or service from the beginning to end as a part of it. So the purpose of value stream mapping is to understand the value flow. Already we had seen the term value flow, which is nothing but product which is manufactured using value stream based on the customer demand. So here, through the value stream mapping, we'll be able to understand how the product is flowing, starting from the receipt of raw material till the product is being sent to the customer. Let us see a simple value stream map. In value stream map, we'll be constructing two types of maps. One is current state map, another one future state map. Current state map will show presently how the activities are going on, and future state map will show the kind of an improved scenario. If you could see in this value stream map, okay, so it is based on the SIPOC cycle. We have the supplier who is supplying the raw material, which forms the input, and we have a sequence of process and the output which is being delivered to the customer. So there are conventions I'll be discussing in the next case as a part of it. So here for we should try to understand from this value stream map, okay, the raw material, how the raw material is being supplied by the supplier, in what frequency, how many number the supplier has to supply, and again the customer, to how many units we have to products to be delivered, in what frequency we have to deliver, and so on. And accordingly, how the customer order is being taken by the production control division, and how they are regulating the order to the supplier, and how they are providing all kind of instructions to the process owners. So for every process, we need to find out the cycle time, changeover time, and we need to find out how many operators are there, and accordingly we need to calculate the uptime and other parameters. And here the customer requirement is 4,000 per month, and the manufacturer is delivering 1,000 per week as a part of it, and the daily production is 200 numbers. and we have this raw materials, double work in process inventory, finished goods inventory. Total inventory is 4,400 numbers. On converting to time scale, taking the ratio to daily production, we'll be getting 22 days of inventory, which is a very big number. So here we need to analyze. After deriving this current state map, we need to analyze the current state map. So here the first aspect is nothing but understanding customer requirement. So customer requirement is 4,000 per month and it's being delivered 1,000 per week. Even the customer, we want a daily delivery of product, but it may not be possible depending on the logistics and other constraints as a part of it. Next one is recognizing the supplier capabilities and constraints. So based on the customer demand, the 1,000 numbers of raw material is being delivered by the supplier as a part of it. That is the economical quantity to be supplied as a part, and the timely supply of raw material is also very, very essential as a part of it. And third one is nothing but we have to identify which activities are adding value and which are not adding value. If you see the kind of processes, inspection of castings, which is not a process which is adding value from customer's viewpoint because it is supplier's responsibility. So we can eliminate the castings inspection. Next, we have two drilling process, drilling location holes and fixing holes. We can explore the possibility of combining this drilling process and again with the boring process. We have two drilling process and one boring process. We have to explore whether is it possible to combine these three processes. Okay. Next is nothing but a fixing task, and the next one is assembly and test, whether it is possible to combine. So here we have to find out any activity which does not add value from customer's viewpoint, whether it can be eliminated or is there any possibility for combining the process and so on. We have to explore. Next one, we have to compute takt time and we have to find what prevents us in producing this thing. So takt time is a unique parameter with the lean theory. So here the takt time is calculated based on available time to customer demand. That is nothing but takt time states the time in which the activities have to progress in line with the customer demand. That is time, it has to be regulated based on the customer demand. The cycle time of the process have to comply with the takt time as a part of it. So depending on the allowances, we have to subtract from the shift time and we need to calculate the available time and we have to take the ratio to customer demand and we have to see whether the processes are complying with takt time or not. If there is any deviation, we have to explore why it is not complying with takt time. Okay. Next, we have to compute the inventory, calculate the inventory, and we have to convert to time scale and we have to explore how we can minimize it. Say if we have seen here inventory is 4,400 numbers, converted to time scale it's 22 days, which is a very bigger inventory. So why we are converting inventory to time scale is nothing but we should know what is the magnitude, and it will also facilitate the calculation of lead time. That's why we are converting, and we have to explore the possibility of minimizing the inventory. Say for example, when we try to synchronize the process and we are adopting the pull concept, we can try to minimize the WIP. Okay. Next, we have to explore whether it is possible to transform a kind of a batch scenario to a single piece flow. That means the product is moving one by one without any delay, without any waiting and so on. Next is nothing but line balancing. Whether is it possible to balance the line as a part of it. So that once we balance the line, we can ensure that the cycle times of the process are closer to each other and there is no waiting between the machineries and equipments as a part of it. So these are all the different perspectives which I discussed now. Now this is the thing but the future state map. We could see from 6 process it has been reduced to 2 process because inspection of castings is being eliminated, 2 drilling and 1 boring process is being combined, and a fixing and assembly process testing process is being combined, and it is being made pull as a part of it. From 6 process we could reduce to 2 process, and from earlier there were 6 operators, each one being engaged in one process, and we could convert them into a single operator. Because here, once the operator has completed loading for the first process, because it's a kind of a drilling cum boring operation, which has to be done in a CNC based machine tool, the operator need not be idle. So the operator will take care of the assembly and test. So from 6 operators, we could reduce to 1 operator. And the WIP is being made 0 because the process are becoming synchronized. and the concept of pull is being adopted. So the inventory got reduced to 7 days as a part of it, and definitely there will be space savings and other aspects also, and the compliance with the takt time is also being ensured as a part of it, for which we need to take into consideration the kind of the tooling and the capabilities of the machineries and equipments and so on. This is nothing but a desired or future state mapping. So first we need to draw a current state map, analyze it, identify the improvements, and then go ahead with the future state map, and then we'll be able to identify the improvements as a part of it. Okay, so these are all the improvements as I discussed as a part of it. Okay. So now I'll show another illustration for value stream mapping. So this is nothing but a process map for an automotive component, the various operations. And for every operation, we should measure the cycle time. That is through a stopwatch time study procedure, we need to measure. And the changeover time for transforming from one product to the next product. And we need to calculate the uptime as a part of it, which states that to what extent the machinery or equipment is in active working condition as a part of it. And we have to collect the data for all the process, and then after collecting the cycle time of all the process, we have to calculate the total cycle time, and we need to calculate the takt time, which is the ratio of available time to customer demand. Okay, so the available time will be computed after subtracting the allowances from the shift time, and based on the daily production, when you take the ratio, we will calculate the takt time. So takt time is the time taken to complete an activity in line with the customer demand. Okay. So now we have different inventory data being observed. The first one is raw material inventory, and the last 150 units is the finished goods inventory, and other remaining values are the in-process inventories. And the same inventory data is being converted to time scale. When we take the ratio to the daily demand or the daily production, we'll be able to convert to customer demand, that is to the time scale. And this is nothing but the bottleneck analysis for different process. We could see whether are they in compliance with the takt time or not. If we could see the first three process or bottleneck process, because their cycle times are more than the takt time as a part of it. Apart from that, in value stream mapping, we need to calculate the value added ratio, which is nothing but the ratio of the total cycle time to the lead time. That again is a very important indicator which need to be measured. This is nothing but the current state map, where we could see from the supplier is supplying the raw material, and we have a sequence of process and the output which is being delivered to the customer, and we have the kind of electronic flow of information between customer and the production control, and between production control and supplier we have electronic flow, and the other between production head and this individual process owners we have the traditional flow of communication. For every process, when you are representing, we need to represent the entities with the process name, number of operators, cycle time, changeover time, available time, and off time. Then we need to draw a timeline. So the below timeline is being drawn in such a way. So the bottom segment of the
Sir, your mic is mute. Sir, please. Hello, Vinod sir. Do I audible?
Yes, madam. Yes, madam.
Yes.
It got automatically muted. Now I release. Is it fine?
Okay. Yes, sir. Okay.
Okay, madam.
Sir, sorry for the interruption. Sir, can you make your screen to the full screen, sir? Because we are not able to see. I'm not able to see the full screen actually.
That is the problem with this platform. If I go to the full screen mode, you will not be able to see the content. That's why I have zoomed my content. I have kept to the maximum extent possible.
Okay,
Vinod, sir, sorry,
Vinod,
sir.
there is a provision to share your entire slide. When you are sharing, no sir, so you should select and share your entire screen. So in that feature, when you go with the slideshow, we can see your slideshow, sir.
Let me try it out. Okay.
Please unshare yourself. And
yeah, I'll do it now. I'll do it. Just a moment. Is it fine now?
Yes, sir. Now it's perfect, sir.
Okay, you could see the entire screen.
Entire screen, sir. It's
Okay,
perfect.
good. Yeah,
Thank
thanks
you.
for the session. Okay,
Yes,
bye.
thank you.
Okay, so as we have been discussing about this current state map, so we could see the convention to be followed. Say, for example, this is nothing but the electronic flow of communication. And this is the kind of manual information flow. And for every process, the process name should be to be given with the number of operators, cycle time, changeover time, available time, and uptime. If you see, available time will remain same across the entire value stream, because availability time is being calculated by subtracting the allowances from the shift time. It remains same for all the process, but uptime will vary, because depending on the individual changeover time of the process, the uptime will change. So uptime to be calculated by subtracting the changeover time from available time, we have to take the ratio to available time. So the uptime will change, vary from one process to next. And we need to draw this timeline below the process. So the timeline will have a bottom segment and a top segment. So the bottom segment will correspond to the individual cycle time of the process, and the top segment will have the inventory being converted to time scale. So here the inventory is 5 numbers, the daily production is 100 numbers, we are having 0.05. So the purpose of drawing this timeline is nothing but when we sum up all the time parameters in a timeline, we'll be able to calculate the lead time. That is the significance of drawing. Okay. So now if you could say this future state map, certain improvements are being suggested. Say, for example, the logistics system is being taken care because the time for transit of the raw material took more time, and here it has been brought this level to production. That is, the production leveling has been done as a part of it. Poka-yoke is being done with regard to the tooling for the two process, and the single minute exchange of dice had been brought, and certain improvements are being taken ahead with regard to 5S and the TPM. Say, for example, the kind of the downtime with regard to the two machineries seems to be slightly higher. So accordingly, certain actions are being taken as a part of it. And apart from that, the 5S and other implementation are being done. This is the thing, but the future state map for the given case as a part of it. So I would like to show another case study also as a part of it. So in this, if you could see, this is the current state map, this particular study. And in this, we could see the time for the raw material to be supplied from the raw material storage area to the process consumed more time. There were a single material movement operator. Then later, the material movement operator had been increased by one more as a part of it. And for the second and third process, the kind of uptime seems to be lesser because of more downtime and the breakdowns. So accordingly, the TPM implementation had been done. And with regard to 5th, 6th, and 7th process, the 5S, especially the third element of 5S, is being taken care, CISO. And this is nothing but the kind of fault tree analysis for the shop floor for different machineries, and accordingly the breakdown data had been analyzed, and the kind of the reliability parameters are being measured, and the system reliability is being calculated, and a Pareto chart had been drawn for the breakdown data, and the possible reason for the breakdown had been found, and accordingly actions have been taken as a part of it. And we could understand the cycle time for the first two machineries are higher as a part of it. So they were subcontracting certain quantity, and later by taking ahead with the process capability study and critical process capability metrics, the reconditioning plan had been taken, and accordingly this issue had been sorted out. And the second problem is nothing but the changeover time for the third workstation is found, during which the WAP got accumulated as a part of it, and accordingly, based on the Kaizen principle, the pre-planning tag had been inserted as a part of it. Thereby, the tool fetching time could be reduced. Likewise, certain Kaizens are being implemented as a part of it. Okay, so that's about the value stream mapping. I have shown you one illustrative example from the textbook and two case studies as a part of it. So it might have given you some broad idea of about value stream mapping, which is an excellent and powerful tool as a part of lean implementation. Okay, so the unique advantage with value stream mapping is nothing but while we implement value stream map, many other lean tools also will come as a part of the implementation. Say 5S, TPM, Kaizen, likewise Poke, SMED, likewise other lean tools also come into picture, and it helps us to quantitatively analyze the lean parameters, maybe inventory, cycle time, lead time, and so on. Accordingly, we can very effectively identify the improvement actions as a part of it. With my experience in carrying ahead with the industrial studies, as a part of lean implementation, we have found value stream mapping to be a more effective tool for lean implementation as a part of it. Okay. So as I told, the next tool is nothing but Workcell. So in Workcell, we go ahead with the adoption of the cellular manufacturing or group technology concept and so on as a part of the implementation. So accordingly, we try to aim at the U-shaped Workcell formation, taking ahead with the procedural steps as a part of it. Also, we do the line balancing as a part of it. That's the fourth primary tool. Now, having discussed about the primary tool, next is nothing but a set of secondary tools. So the focus of the secondary tools is nothing but to augment the primary tools as a part of the implementation. Say we had seen as a part of value stream mapping, we have done cause and effect diagram to analyze the reasons for the breakdown. So it is nothing but it's a secondary tool for lean manufacturing, which helps us to identify what is the root cause of a problem. Similar line Pareto chart also gives us certain inferences as a part of it. And I have shown the spider chart or radar chart as a part of 5S auditing, which helps us to analyze, which gives an overview of various parameters of a single shot as a part. Next is about Poke. We discussed it's called a mistake proofing mechanism. So here, as human, we are prone to commit certain mistakes, but the system should not permit the occurrence of the mistakes. That is the mandate of Poke. So in Poke, the solutions are simple, but it is more effective as a part of it. So the next one is nothing but the Kanban, which is a Japanese term which means instruction code as a part of it. So this Kanban systems will provide will try to regulate the inventory as a part of it, and it helps as a part of the full production. Okay, so there are different types of Kanban systems as a part of it. Accordingly, the Kanban system, let us take a very simple example. Say, for example, we are having a kind of an product line, assembly line, which has to produce the sub-assemblies for another assembly line. So from that assembly line, which requires sub-assemblies, a kind of a Kanban code will be sent, a kind of a trolley-based mechanism with a Kanban code will be sent to the main assembly, which indicate how many number of sub-assemblies to be produced and what time it has to be produced. Accordingly, this assembly line will produce and it will send to that line. So this kind of synchronization can be very much facilitated through Kanban system. Next one is automation, which is nothing but an automatic signal mechanism. Maybe a kind of, it provides light, sound, and combination of signals as a part of it. Okay, very good example. When I visited an industry, they have kept a kind of a signal mechanism on the top of the machine tool, which can clearly indicate a red light glows. Then the machinery is having some issues, it's not running. Green light, normal running. And yellow light, if some problem happens because of the quality issues, some problems are happening. So that is a very good indication mechanism. Along with that, the signal, sound signals also will be provided as a part of it. Next, SMED, earlier we discussed, is nothing but quick changeover concept. Ideally, the exchange time between the tooling should be very less as a part of it. It's based on quick changeover. Next, standardize the fixture. It tries to design the tooling with standard elements as a part of it. And as far as possible, we try to go in for universal type of tooling as a part of lean implementation. And also design for manufacturing and assembly will help us to analyze the customer requirements, and we are moving ahead with the kind of interchangeable type of assemblies and so on as a part. Next is just-in-time concepts. We'll try to ensure that the layout organization and ensuring zero defects, flexible workforce, and so on as a part of it, and it is based on the full system. Next one is visual workplace. In lean, always we focus on visual workplace or visual management and so on as a part of it, because we will try to overcome the kind of problems. Say for example, if you see industries shop floor and all, if you visit, they will have some digital displays which shows what is the planned target for that shop, how much they have produced and how much they are deviating. Likewise, they periodically update. So that kind of a visual mechanism will provide a very good understanding for the workers as a part of it, that updates and other things. So in lean, we level best, we develop this kind of visual mechanisms also as a part of it. Okay, so this is about the kind of 10 secondary tools. Okay, so this is about lean manufacturing. As I told, in lean manufacturing, in order to understand the lean system, we should have an understanding on The elements, 5 elements we discussed, tools and techniques, and some governing rules. If you see the governing rules in lean system, it focuses on a kind of a bottom-up approach. In the sense, first we try to find out the reasons for instability. We try to make the system stable. Then we try to focus on work standardization. Standardization will help us to ensure consistency of the process as a part of it. Next, we focus on pull system, transforming from push system to pull system, then level the production. Production leveling means one process will go synchronized with the other process so that there will be no delay, no waiting as a part of it. The process will go in a synchronized way. Then we will go ahead with the continuous improvement. This is nothing but the rules governing the lean manufacturing as a part of it. So with this, we completed the discussion on lean manufacturing concepts. Let me give some time for the participants. So any queries from the participants till now? So kindly get clarified. Participants, any queries or clarifications? Coordinators, are there any questions in the chat box? Are there any questions in the chat box?
Sir, good morning, sir.
Yeah,
So
good
this
morning.
is Shiva from Satyam University. Sir, I have a question that you have calculated the takt time for the batch production, which you have shown in the slide actually.
Yeah.
So in that case, you will be having the setup time, sir. So to change for the one batch, for example, if I'm manufacturing 100 components, for the next 100 components, I have to incorporate the setup time in that one. So how it will affect the takt time calculation, sir? Suppose if it is a continuous production, it's not a matter. So we will not have the setup time in that one, means mass production or the continuous production. So in batch time, definitely we'll have the setup time. How do we incorporate that one in the takt time calculation, sir? Because the setup time, obviously, it will make a change in the takt time. So it might affect our delivery time.
Yeah, it's a good question. But if you see in general, the takt time is being calculated as a ratio of available time to customer demand. The takt time is being calculated for the entire product line as a part of it, for the entire shop. If you see from the shift time, we have to subtract all standard allowances and we will calculate the available time and we'll take the ratio to the customer demand as a part of it. As you mentioned, this concept of the setup and other things will come as a part of the changeover time and they will get connected with the uptime and so on as a part of it. Okay, but that will not have a major influence on the takt time.
Okay, sir. Sir, this uptime is only for the machine utilization or the whole thing will come, sir?
No. Uptime is for every individual machineries and equipments. We need to calculate uptime, which is an indicator of what is the kind of the complete interaction that is happening in the machineries.
For example, you have mentioned it as like this assembly means it's a fully man work, so we can utilize 100% over there. For example, if you are compounding any mills, so suppose if it is gets heat up over there, we have to stop the machine for 30 minutes or 20 minutes. So that will reduce the uptime of the machine. Am I right, sir?
Yeah. It depends on the kind of production. It depends as a part of it. Yeah.
Okay, sir. Thank you, sir. Thank you so much.
Yeah. Fine. Any other questions or clarifications from participants? Coordinators, are there any questions in the chat box?
There is a hand raised by Sonal Khurana, madam.
Yeah,
ma'am. Do you have any question, ma'am? Sonal, ma'am? Hello. I think, sir, we can continue, sir.
Yeah. Okay, fine. Okay, so next, so having discussed about this lean manufacturing concepts, I believe with the available time, whatever insights to be provided, I have given as a part of it. Each tool requires a kind of considerable amount of time, but to give certain insights, I have gone through the concepts within the time. And so next module of my presentation is on Six Sigma concepts. So as we all know, the Six Sigma concept originated from the Motorola industry somewhere in 1980s, and then General Electric, they went ahead with the implementation, and during the recent time, organizations in the diversified sectors have applied Six Sigma as a part of it, and Six Sigma is found to have certain edge over benefit when compared with the TQM and business process engineering as a part of it for ensuring quality. If you see, the kind of some of the fundamental aspects of Six Sigma. Sigma is nothing but the standard deviation, which is a measure of variability. And here Six Sigma is a quality improvement philosophy which focuses on defect elimination by means of reducing process variations. So what is a defect? It is kind of an entity that is not in conformance with the specifications, not in agreement with the acceptable limits. If we try to compare TQM and Six Sigma, because Six Sigma is an advanced strategy of TQM, but let us try to see certain differences, minor differences between TQM and Six Sigma. TQM, we all know it's a management philosophy for quality improvement, whereas Six Sigma is a philosophy that focuses on defect reduction and ultimately cost reduction. In TQM, we try to bring about the total employee involvement, whereas in Six Sigma is we try to focus on involving everyone, but also we may go with the project approach by involving the kind of trained workforce as a part of the projects. And in TQM, the kind of top management support is very essential as a part of it. And Six Sigma, the kind of accountability as a part of the management is also very essential, which is concerned with the results. These are certain kind of subtle differences between the TQM and Six Sigma approaches. And if you see some of the metrics of Six Sigma, we have metrics like defects per unit and the kind of defects per million opportunities and so on as a part of it, with reference to the standard deviations. And if you see the kind of inference from Six Sigma, it implies 3.4 parts per million defects or defects per million opportunities as per Motorola's definition. And here it's a kind of a business concept or philosophy that ensures high quality and defect-free process. And as we understood, it had its origin from Motorola Corporation, and further it had been developed by Michael Harry. And the Motorola Corporation, for implementing Six Sigma, they have been awarded Malcolm Baldrige National Quality Award. And normally Six Sigma is being taken ahead with the projects approach, and it is based on the DMAC, define, measure, analyze, improve, control approach. Now let us try to understand the concept of Six Sigma. If we take a 2 Sigma process, the process capability CP is somewhere 0.67, and it requires heavy process control, whereas 3 Sigma is the kind of a analogy we take with the normal manufacturing process with the CP1, and it again requires heavy process control. And for 4 Sigma, CP is around 1.33, and here we go in with the ready user inspection, the usage of quality control charts. And with 5 Sigma, CP increases to 1.67, and we may go ahead with selective usage of the control charts. And for 6 Sigma, CP is of the order of 2, and we go ahead with reduce the control strategies and so on. If we try to understand the meaning of the process capability, it is nothing but the ratio of the design width to process width. That is nothing but the ratio of the difference between the specification limits to the difference between the control limits as a part of it. So we need to have an understanding on this mathematical concepts behind the Six Sigma. And if you see compare the defects per, that is parts per million defects for 3 Sigma process, somewhere it is 66,807 industry average, whereas for 6 Sigma process, it's about 3.4 parts per million defects, world-class standard. So almost for 6 Sigma process, it's of the 3.4 to the ratio 1 million is approximately 0 defects. So we are ultimately moving ahead with the 0 defect manufacturing process as a part of it. And in a typical Six Sigma curve, when we try to look the specification, the kind of control limits will be the mean plus 6 times standard deviation and mean negative 6 times standard deviation as a part of it, with kind of total process width of the order of 12 Sigma as a part, whereas it is of the order of 6 Sigma, the process width with regard to a 3 Sigma process. And if you take the kind of process capability ratio, it is the difference of the specification limits to that of the 6 Sigma as a part of it. And accordingly, we try to calculate the CP and so on as a part. So the CP index and the defects per million opportunities, we could see the kind of the correlation between process capability index and DPMO. And if you say the kind of implementation aspects of Six Sigma, it's a 5-phase process we go ahead. First, we try to ensure management commitment and employee involvement, and we go ahead with data gathering as a part of it. Then we train the people, train the workforce, then we develop the monitoring system, Then we focus on the business process to be focused business process, and then we go ahead with the Six Sigma projects, and we just based on the Kaizen approach, which is continuous improvement as a part of it. The 3 dimensions of a Six Sigma concept, if you see, the first dimension is the organization dimension, where we are focusing on top management commitment, and we are focusing on the customer needs and customer requirements and the quality team enabling. And the methodology, if you see, either we go ahead with an DMA-IC, that is a DMAC approach, or we have another one, DMA-DV as a part of it. DMAC is a widely used approach for process-focused projects. Next, we have the tools and techniques, maybe like we have a Pareto chart, cause and effect diagram, regression analysis, design of experiments, trend charts, and failure mode effect analysis, variety of tools we try to use. So whereas in a 3 Sigma process, we have the 3 dimensions being in a Six Sigma process, one being organization, second methodology, and third being tools and techniques. Okay. So if you see various tools of Six Sigma, as we mentioned, it starts with process mapping, Pareto analysis, gauge, R&R studies, tolerance analysis. Then we have hypothesis testing, design of experiments, statistical process control, regression analysis, and so on. Then if we take the organization for Six Sigma, we have green belts. They are nothing but the team members of the project. Next, we have black belts, the team leaders, and we do have master black belts. They are nothing but the instructors or coaches. And we do have the project champions who are responsible for selecting the projects and knowledge sharing and so on. These are the different levels in organizing the Six Sigma projects. So if we take the principles of Six Sigma, we have the customer focus, understanding customer requirements and taking ahead with the customer requirements. Next, leadership. The kind of leadership quality is like the mentoring quality as a part of it, and to provide as far as possible support as possible. Next, we have to ensure that the workforce, they are innovative and they are proactive as a part of it. And we need to focus on the boundaryless integration as a part of it without any barriers. And the focus should be on world-class quality. And the entire process is driven by facts. And we totally go ahead with management of the process as a part. So these are the different principles governing Six Sigma. And if we take in Six Sigma projects, also in Lean and Lean Six Sigma projects, we are focusing on project charter, which is a very important document which has to be prepared, which will contain the goal of the project, who are all the team members, and what is the mandate of the project, how much time frame it will take, what is the starting date and what is the probable ending date, what are all the milestones to be done, what are all the activities for the team members, and how much will be the cost incurred as a part of implementation, and what are all the kind of benefits, financial benefits, and so on. So the project charter need to be drawn for any typical Six Sigma or Lean Six Sigma projects. Okay, as I mentioned, the quality team, we start with the green belt, who will take ahead with less complex projects, and then black belt, they will mentor the green belts as a part of it, and they will take ahead with even the high risk projects. Then the master black belt, who are responsible for selecting the projects, and they have expertise and they try to mentor the green belts and black belts likewise. These are the different levels of quality team with regard to a Six Sigma process. And if you see the scope of Six Sigma, we are discussing from manufacturing concept. These concepts are very well applicable for service industries, hospitals, insurance type of corporations, and so on. And if we see the methodologies, as I mentioned, normally we'll go ahead with the DMAC approach: define, measure, analyze, improve, control. And we have another approach, which is the define, measure, analyze, design, and validate as a part of it. So it's a 5-phase approach, and we will discuss about the context of the projects. So the DMAC is widely used approach for improving the existing business process, and DMA-DV is used with regard to the product development projects, especially in developing new product and process designs and so on. So that's the difference between the DMAC and DMA-DV approaches. So in DMAC approach, there are 5 phases, as we had seen. So in the define phase, we try to identify the customers, their priorities, the business goals will be defined, and we'll form the team, and we will define the CTQs, critical to quality characteristics, which will have a major impact on quality. And here we should have a very clear understanding about the voice of customers, the requirements, and the project goals. And measure, we'll focus on the current aspects of the process and we'll collect the relevant data. Then in measure phase, we'll focus on identifying the key internal process that influence CTQs and we'll measure the defect rates as a part of it. Next, in analyze phase, we'll try to determine the most likely causes of defects and we'll try to identify the factors that will have the process variation and so on. In analyze phase, we'll try to investigate and verify the cause and effect relationships as a part of it, and we'll try to find out the root cause of the problems and we try to take suitable actions. And the improve phase, we try to enhance or optimize the process based on the data analysis, and we use statistically designed experiments, okay, mistake proofing, and we do pilot run and so on. So in the improvement phase, we try to conform the variables and we will try to identify the maximum acceptable range for the key variables, and we go ahead with the continuous monitoring of the process to ensure that the parameters are within the acceptable ranges. Next, in control phase, we go ahead with the control charts plotting and so on to ensure that the parameters remain within the acceptable ranges with the modified process, and we need to ensure that the deviations have to be controlled as a part of it, and we go ahead with the statistical process control and the production boards, and we go ahead with the visual controls and so on. Accordingly, we monitor the process. Okay, so next we will go ahead with the kind of DMA DV approach. So we can completed the DMAC approach. Next we will go ahead with the DMA DV. So here we will define which is being applied in the context of the new product or process designs, and define. We will design the goals which are consistent with the customer demands. And in measure, we try to identify the critical to quality capabilities, the product capabilities, the risk and the production process capabilities. And in analyze, we will develop and design the alternatives. And in design phase, we will design the improved alternatives as a part of it, alternative designs. And in verify, we go ahead with the pilot runs, we go for validation, and we will try to develop the product in line with the requirements of the process owners. That is the second approach, which is called DMA DV approach. So if you see the benefits, we'll be able to reduce the operational cost, improve efficiency, improve accuracy, and we will try to ensure the customer service, and we will ensure compliance with the regulatory norms and so on. Okay. That's about the second part of the discussion, which is Six Sigma. And again, it's a powerful strategy which will help the organizations to go ahead with moving ahead with the zero defect manufacturing process as a part of it. Okay, so with this, we will go ahead with the discussion on Lean Six Sigma. So having discussed about the lean manufacturing concepts and the Six Sigma, then the concept of Lean Six Sigma has emerged, because Lean has the focus on waste elimination and Six Sigma has the focus on defect reduction. Then they talk about this integrated strategy for the business process excellence, Lean Six Sigma, which is a very powerful strategy as a part of it. So here, why we need to go ahead with this LSS? Okay, here, when we go ahead with the Six Sigma implementation alone, we may not be able to remove all types of waste with the process. And again, if we go ahead with the lean implementation alone, we cannot ensure that the process is in statistical control and will be able to control the variations. So in this context, this taking these considerations, the organizations have gone ahead with implementing these two methodologies in a synergistic way, and this powerful strategy for continuous improvement and process optimization have been brought, which is called Lean Six Sigma as a part of it. It's very interesting, and it has to be done very meticulously as a part of it. Okay, so here in Lean Six Sigma, so it's a business strategy that has its focus on enhancing the process performance, which results in customer satisfaction and improved bottom line results. And here it provides the concepts, methods, and tools for the changing process. It's a widely applied and effective leadership development tool. So here, in Lean Six Sigma, here we will focus on maximizing the value-added aspect of operations, And here we will evaluate the incentive systems with the focus on the global optimization. And here we will go ahead with the decision-making process, management decision-making process very meticulously, and we will try to understand the relative impact on the customer. If you see the benefits, the profit enhancement and the customer satisfaction, and we'll be able to reduce the operational cost, cycle time reduction, and reduction in defects, reduction in breakdown time. We'll be able to reduce inventory, improve quality, and production capacity improvement. So if you see the challenges involved in implementing LSS, so some of the challenges, there are many research studies which shows the challenges analysis for Lean Six Sigma. Some of the commonly identified challenges are, there is no proper understanding on the Lean Six Sigma methodology. And the kind of the training effectiveness as a part of Lean Six Sigma is not up to the level as a part of it. And the kind of a roadmap for implementing Lean Six Sigma is missing as part of it. And the sustainability aspects of Lean Six Sigma is also missing. Okay, so such challenges we need to have an understanding as a part of it while implementing Lean Six Sigma. So in this context, in order to deal with these kind of challenges, or we do some barriers analysis and we try to identify the influencing factors, then we try to come out with a framework. What is a framework? It is nothing but an architecture which clearly shows how the different tools and techniques and how different entities have to be linked there in order to come out with a very good architecture for implementing Lean Six Sigma. Okay, so here there are certain frameworks being proposed as a part of it. So as a part of the frameworks, the readiness factors to be analyzed, the challenges, readiness factors to be analyzed, and accordingly those inputs also to be taken into account while developing the frameworks. Okay, so this kind of a framework has to be supported with the roadmap. So in the context of Lean Six Sigma, when we want to go ahead with the implementation, we have different phases like conceptualization. First, we need to find out the different entities, and we need to understand the challenges, barriers, and we need to conceptualize the elements. Then we have to go for initialization. That is nothing but starting activity. Then we have to go ahead with the implementation of the framework, and we have to sustain. As I mentioned, in the last step will be sustenance as a part of it. Either maybe a lean project or Six Sigma or Lean Sigma project, the sustenance is a greater challenge as a part. So if you see the implementation roadmap, okay. So first we need to, in the conceptualization phase, we need to identify what is the need for Lean Six Sigma. We have to plan the resources, and we need to understand what is the expectation of the management and so on as a part. But if you see initialization phase, we need to go for selecting the project. So here, project selection is a very important research problem or research question. Which project to be selected? Say for example, this kind of a question arises even in Lean. Okay, say I'm going to implement 5S in an organization, which it is not possible to go for the implementation for the entire organization at a single stretch. We have to go with a phased approach. So I need to have some priority where I can implement 5S. So let me ask this question to participants as a part of it. So I have different areas for implementing 5S. Which one to be selected in the initial stage? Okay, could anyone respond?
At machine level.
Yeah.
At machine level.
That's fine. That's fine. That which okay. Wow. What kind of what type of machineries I should take ahead? Which machineries I should give priority? Likewise.
Vertical milling center and all.
No, actually, it's good. So when you want to implement 5S, okay. So normally we go ahead with different. We try to have different zones or different product lines in an industry. So which area to be selected for 5S is the one which has maximum disorganized layout. There is a lot of transportation waste, a lot of motion waste is happening. Totally, the workplace environment is not at the level of, it's not so clean and so on. So such area is the one where we have to implement first. Say for example, I want to implement TPM. Okay, I have different product lines. So in every product line, there will be different machineries. So we need to calculate the overall equipment effectiveness, OEE for different machineries or equipment. I need to select the machineries or equipments, layout with the, I need to select the layout with machineries or equipments with lesser OEE. There I have more challenge for implementation. Likewise, selecting the project is very, very important in the context of Lean Six Sigma and Lean Six Sigma projects. There are many research studies are being done. What is the approach? How we need to do? Because it's not based on a single criteria or a single parameter. It involves multiple criteria. So definitely those governing criteria need to be identified and we need to solve. That is from a research perspective. From practical perspective, we try to identify where it is critical to Lean, the area or the zone which is critical to Lean, which is critical to Six Sigma. Such area we will take ahead as a part of it. Next, as a part of the initialization, selection of the green bells, yellow bells, and so on. Then we form the team and we train them. Next comes the implementation. We have DMAC phase: define, measure, analyze, improve, control. In define phase, I try to form the project charter. I develop a SIPOC cycle, critical to quality metrics I analyze. In measure phase, we go ahead with the data collection. We go ahead with the measurement system analysis. Then stability study and the parameters we collect in. Next, analysis process. We go ahead with the process analysis, cause and effect analysis, and so on. Then improvement phase, we try to generate the solution. We try to prioritize them and so on. Then comes the control phase. The last phase is with sustenance. In control phase, we have to standardize the solution. We have to develop the control plans, sustainability plans as a part of it, okay, and so on. Then we have to monitor the results. We have to plot the control charts. Then we have to explore for horizontal deployment as a part of it. Then we should have strong rewarding and incentive schemes. That is very, very essential. Because in all these are nothing but the advancements of the TQM philosophy. When we look about the kind of recognition and motivation scheme, is very, very essential. Also in Lean, we discussed it. The kind of innovative solutions has to come from the workforce, because there are tools, different tools we have seen. But when they are being subjected to implementation, it is up to the organization to come out with the solutions for the problem, for which the innovative thought process is needed. So we have to recognize the efforts. If you visit the industry, they will have, they will try to display employee of the week, employee of the month, such a rewarding and recognition schemes, which will help the employees to get motivated, enthusiastic towards bringing about this kind of challenges. Because even more, the situation will be highly complex when we go ahead with an industry 4.0 based implementation and all. Such product, process, and system level innovation is very, very essential as a part of it. Okay, this is nothing but a complete roadmap for LSS implementation. Okay, so this is one of the framework we developed in one of the research studies. It's based on the DMAC process. In define phase, we indicated we analyze the management initiatives, we identified the problem, we mapped the current state, we drawn the current state map, we identified the project charter. In measure phase, we did data collection of different time parameters. We did activity categorization, value added, non-value added, necessary but non-value added. Then waste categorization, 7+2 forms of waste we did. Next, in analyze phase, we plot the cause and effect diagram, Pareto chart, and we analyze the root cause of the problem. Then in the improve phase, future state map had been drawn, then validation and sustainability plans along with Y-way analysis. In control phase, we plotted the control charts and stability plans. This is nothing but in one typical study, this is the framework we developed for Lean Six Sigma. Okay. Another one classical framework I would like to show from the research studies, okay, as a part of it. Okay, this is again another framework which is being contributed as a part of it. So here as a part of the define phase, they have developed the big picture map, brainstorming, and so on. And in measure phase, they established the process capabilities and process monitoring. And analyze phase, they did the CTQ characteristics and variation sources they identified. Then improve phase, they have gone with the design of experiments, establishing the 5S system, TPM, and so on. Then in control phase, they have gone ahead with the control charts plotting and the sustainability plans, mistake proofing, and so on. Again, it's another framework for Lean Six Sigma. If you see in another study, we have gone ahead with the kind of DMAC along with the sustainability phase, and then we have gone ahead with the kind of the Lean knitting through recognizing the value from customer's perspective, then measuring the value stream based on the parameters, then analyze the value stream. We try to identify the improvement proposals. We make the flow to happen and try to achieve perfection as a part of it. So here, this is Six Sigma on the lean cycle. They are being integrated and taken ahead as a part of it. And if you see, this is another framework which we took from the literature as a part of it, as a part of the define phase, measure phase, analyze, improve, control. They have done different activities, and accordingly, the process excellence had been ensured. So here, in this framework, taking ahead with the first framework which I have shown, I would like to present a case study which we did for an industry. So this is the thing with the project charter, which clearly shows, okay, the experts team being involved with the experts coordinator and the customers and the team members. What is the starting date of the project? What is the planned completion date? And here the project is to improve, focused on improving the first time right percentage. And we have gone ahead with using different tools like value stream mapping, design of experiments, cause and effect analysis, and so on for complete DMAP phase. What is the starting date and completion date have been indicated. So this project chapter has to be developed for Lean Six Sigma projects. So this is the complete value stream map we developed as a part of it, current state mapping as a part of it with all time and inventory data as a part. Next, we did the waste analysis. Along with 7 waste, we have the 13 losses. We mapped them as a part of it. This mapping helped us to identify that which forms of waste are predominant as a part of it. Then with this, we computed the value addition percentage as a part of it. You could see the kind of a pie chart which shows the proportion of value adding and non-value adding activities as a part. Next, we did a cause and effect diagram and a Pareto chart as a part of it to analyze the root cause of the defects. And this is about the future state value stream map, where we brought ahead with the kind of the quick changeover concepts, and this kind of Kanban systems are being implemented as a part of it. And accordingly, other improvements are being focused. And thereby, the control plan, the value stream mapping helped us to reduce the lead time, and the fault tree analysis helped to improve the reliability. And we focused on improving the first time right percentage and so on. As a result of this, the defects per unit got reduced by 50%, OEE got increased by about 17%, and changeover time got reduced by about 25%. First time yield we could improve, and manufacturing lead time got reduced as a part of it. This is about one study which we did as a part of Lean Six Sigma for an automotive component manufacturing company. And I would like to show the second Lean Six Sigma study. This is the project charter. We did it for an electronics component manufacturing organization, and the scope of the project is to reduce the defect and to streamline the process, and we want to reduce the defect rate and improve the first time yield and customer satisfaction, for which we have used the tools such as Pareto chart, cause and effect analysis, GMAC, and DOE, and we have given the starting date and the completion date as a part of it. And this is, I think, with the current state map, which is being drawn as a part of it with time and inventory data. And this is the thing with the different products and the kind of the percentage defects and the cumulative defects are being found as a part of it. And this is the thing with the cause and effect diagram which is being drawn as a part of it. And we have done the design of experiments, statistically designed experiments as a part of it. And these are all the results of the design of experiments. And we focused on the improvements in terms of Kanban implementation, fault tree analysis. We did Kaizen and 5S and TPM and the kind of inspection as a part of it. And we had gone with the kind of the signal to ratio analysis as a part of it, as a part of the design of experiments. And we analyzed the cost. We did cost analysis, and thereby we could quantify the improvements. The first time yield got improved, and the process capability got enhanced. The overall equipment effectiveness got improved by about 10%. Defects per unit got reduced, and changeover time got reduced. The manufacturing lead time got reduced, and WAP got reduced as a part of it. So this is about the second case we did as a part of the Lean Six Sigma implementation. Okay, so before I go ahead with the certain discussion on the Industry 4.0 based initiatives, till this stage, are there any clarifications or queries from participants?
Yes, sir. There is a question in chat box from Abhay Kurant. how Six Sigma concept can be applied to education institute?
Yeah, it's a very good question, because we know pretty well, as a part of the education institutions, we have to comply with the quality initiatives being given by the National Board of Accreditation as a part of it. And as a part of it, we focus on different initiatives on enhancing the teaching learning process as a part of it. So we do the kind of the course outcomes, program outcomes, their mapping, the attainment of course outcomes, and other analysis we do as a part of these initiatives. So all these initiatives are focused on enhancing the quality of the teaching learning process as a part of it. So thereby, the excellence in teaching learning could be ensured as a part of it. So that's the reason we go ahead with these kind of quantitative analysis. Also, we do quantitative and qualitative analysis. All these we could try to correlate with the kind of quality excellence approaches which we follow in manufacturing in the name of the Six Sigma and so on as a part of it. So many of the tools and mechanisms which we adopt, they are very relevant with what we do as a part of it, because as a part of these initiatives, we try to bring into account these kind of analogies. So we could correlate with these kind of analogies and we could go ahead as a part of it. I hope I answered the question.
Yes,
any other
sir.
questions? Yeah. Any other questions in chat box?
No, sir, there is no any question in the
Yeah.
chat box. But there is one thing, sir. On your shared screen, there is a hide. The ribbon is there, which you can press hide.
Yeah, fine.
Yeah.
Thank you.
Okay. Thank you, sir.
Yeah.
Okay, you can continue, sir.
Okay. So now we should think from the viewpoint of Industry 4.0, because now we are moving into Industry 4.0, and we know pretty well the organizations have started the initiatives as a part of it. Typically in Industry 4.0, we know we are moving ahead with the complete digitalization, wherein the backbone for Industry 4.0 system is cyber physical systems, which takes into account the digital twin, integrating the kind of linkage between the physical world and the digital world as a part of it, which are being supported with the technology such as Internet of Things, Internet of Services, big data analytics, additive manufacturing, and so on. So now the manufacturing trend has been changing, and definitely all these process excellence methods which we are doing has to be aligned with the Industry 4.0 practices. Because ultimately we are moving towards the kind of a smart factory. So if you see in research perspective, a lot of issues have started, a lot of avenues are there on developing lean systems for Industry 4.0 and Lean Six Sigma for Industry 4.1. So as a part of it. So because if you see, many of the concepts have been given keeping in mind maybe an Industry 2.0 or Industry 3.0, a kind of a paradigm. But now in Industry 4.0, we are going ahead with a complete digitalization of the process. And there will be a lot of interactions across several entities, like a human-machine interaction, human CPS interaction, robotic CPS system interaction, human robotics interaction. Lot of interactions will be there. And if you see the kind of a shop layout, it has to account for all these interactions, and it has to be completely reconfigurable, and higher levels of flexibility and versatility it has to take ahead as a part of it. So now all these paradigms, all these concepts, we have to think from such a viewpoint. So I have shown you different secondary tools as a part of lean implementation. There are certain tools which have very good relevance for this Industry 4.0. Say for example, in automation, okay, we are discussing about the signal mechanisms, which is nothing but a light and sound signal. So it has to be interfaced with the sensors, and accordingly through the IoT based mechanisms, it can be interfaced. I have a spider chart. Various parameters have to be updated as a part of it. I can go with the kind of synchronizing with the signal-based mechanisms as well as a part of it. I have the Kanban mechanism. I can interface with the actuators, and I can deploy the Kanban systems taking into account these challenges as a part of it. So now there are studies. And when we teach these courses also, we have to take into account these industrial challenges as a part of it. Now, this slide shows how a Lean Six Sigma approach have to be interfaced with an Industry 4.0 based technologies, because we had in Lean Six Sigma, where in the DMAC process we try to integrate Lean and Six Sigma tools as a part of it. Now, along with this, there is another dimension which is Industry 4.0 based technologies, maybe a cloud-based system, Internet of Things, big data analytics, machine learning, deep learning, additive manufacturing, and so on as a part of it. Let us take a very simple example and try to understand how these Industry 4.0 based technologies have to be done. Say, for example, I have a machine tool. I need to monitor the overall equipment effectiveness. That is through the availability, performance, and quality related parameters. So such data have to be retrieved through the sensors, and such data will be stored in a cloud, because if you take in an industry, there will be different machine tools. All data will be stored in a cloud, and the cloud will have such data from different organizations. Every organization will have different layouts, and every layout will have different machineries, and the cloud will have data from different organizations. A manager who has to remotely monitor the OEE of his layout through the cloud system, through IoT based system, the information will be retrieved through the manager in a remote way, so that the manager will be able to understand what is the level of OEE with regard to the machine tool of that particular layout of his industry. Likewise, a lot of challenges are there as a part of it, and it is more interesting as a part. So now definitely these concepts have to be aligned with this Industry 4.0 based technologies. So such challenges we need to take ahead as a part of the implementation, and it is more interesting to work with these kind of concepts as a part, because they involve a lot of technological integration and so on as a part of it. So definitely this will help us to go ahead with supporting industries, because from academia, when we do the research from an academic perspective, it has to be linked with the practice as a part of it, and that kind of the practical relevance we can ensure when we are going ahead with the joint project with the industries, because industries, they go ahead with this kind of implementation, the kind of the techniques, methods, approach we develop from academic research has to be supported with the industries as a part of it. So that will give us a fair idea, and that will contribute to the research ecosystem. That is most essential as a part of it. Okay, so in this these programs, we should try to understand the essence of such research as a part of it. Okay, so now we shall devote time for the participants. Okay, I think there are 2 hands being raised from participants. Okay, so let me try to respond to them if they have any questions. Kindly go ahead with the questions. I think we have another 5 minutes, so let us try to comply with the time. Any questions from participants, feel free to ask me.
Participants are free to ask any question. I think, sir, there is no question.
Okay, so let me try to give some insights as a part of it before we formally close this session. So the faculty and scholar participants who attended my session. So in my session, I focused on the concepts of lean manufacturing, Six Sigma, Lean Six Sigma. I have spent time on the fundamentals to provide some fair idea about these concepts, and we went ahead with the practical case studies. I have shown wherever possible, and the research avenues I would like to highlight. Although I highlighted certain avenues, I would like to highlight certain avenues also as a part of it. In the Lean Six Sigma, Lean Six Sigma approaches, it's more interesting, and they are having very good practical relevance. So the scope for implementing these techniques in industries is very essential as a part of it. And now, as a part of Industry 4.0 implementation, we have very good scope for deriving the concepts in line with these industrial developments, and definitely we have to go with these kind of joint projects with the industries as a part of it. So in this, developing the framework, either maybe in the context of a Lean Six Sigma, is more challenging, and we need to do it. And say, for example, this kind of barriers or factors analysis or challenges analysis is also very essential, because these kind of concepts are being implemented across the diversified industries, starting from product focused industries, process based industries, the kind of service industries as a part of it. And maybe when we go ahead with the kind of small scale industries and across the diversified industries, we need to study these concepts as a part of it. And definitely we need to take into consideration the kind of the industrial challenges, present industrial challenges as a part of it. And the kind of modeling we do, maybe from a structural modeling perspective or statistical modeling, again, those aspects are also very, very essential. And if we look into the Lean Six Sigma research, it's more interesting. Initially, we had only the integration between the Lean and Six Sigma. So in a DMAC process, we try to integrate the Lean and Six Sigma tools. Then we had the challenges of bringing sustainability. So in line with the sustainable manufacturing concepts, we had another aspect of bringing ahead with this environmental based initiatives as a part of it. Now again, we have another challenge ahead of bringing ahead with the kind of smart based concepts as a part of it. Likewise, the research is advancing, and as faculty members and scholars, we do the academic research, we need to take ahead with these kind of joint initiatives with the industries as a part of it. So I request all participants, including the faculty members and research scholars, okay, so to take ahead with these kind of initiatives as a part of it. So the kind of insights which we derive from this FDP will help us to offer these kind of courses, and maybe those who are offering already similar courses, we have to try to expand in line with the kind of the research advancements and the industrial developments as a part of it. And we can identify very good projects for our students, and we can take ahead with the joint projects with the industries as a part of it. So this will help you as a part of it. So I wish all the participants okay, kind of very good, you'll be having very good takeoffs from this, from different sessions of this FDP, and I wish you all the best as a part of it. And I would like to thank the organizers, Dr. Shruti and other coordinators, for inviting me to deliver this lecture. Okay, thank you all. Have a fine day as a part of it, and I try to have very good takeoffs from this FDP. Thank you all.
Thank you very much, sir, for this informative session. Sir, many of the participants are requested to provide the PPT. If it is visible for you, please share the PPT with me so I can circulate it among the participants.
Yes, madam, surely. I'll take some time and then I will try to send you. Okay,
Okay, sir. Thank you very much, sir. Thank you very much, sir.
Okay. Thank you all. Okay, have a fine day. I hope the coordinators, I complied with the time. I completed in right time, I think. Okay, fine. Okay.
Yes, sir. Yes, sir.
Okay, fine. Thank you all. Okay, fine.
Have a good day, sir.
Thank you, ma'am. Have a good day. I'm leaving the meeting. Okay.
Yes, sir.
Okay.
Our next session will be started at 11:30 sharp. So I request all to please join the next session on the 11:30. Thank you very much.
Thank you, ma'am.
Thank you, madam.